What if I told you that one of the most powerful regenerative tools in your body is something most people spend their lives trying to get rid of? A man in his 30s suffered a catastrophic neck injury. His spinal cord was damaged. He couldn't move his arms. He couldn't move his legs. In medical terms, the outlook was devastating. For most people, that diagnosis means a lifetime of limitation. But researchers tried something extraordinary. They didn't turn to a synthetic drug. They didn't implant a mechanical device. Instead, they looked inward to his own body fat. Doctors performed a small liposuction procedure and collected his fat tissue. Inside that fat were stem cells, powerful, adaptable cells capable of becoming different types of tissue depending on where they are placed. Scientists isolated those stem cells, concentrated them, and injected them directly into the damaged area of his spinal cord. And something remarkable happened. New tissue began to grow. Over time, he started regaining movement. Arms, legs, function that once seemed permanently lost. Now, this isn't science fiction. It's early-stage regenerative medicine. It's still being studied. It's not yet routine treatment, but it reveals something profound. Your body is not passive. It is not simply aging and declining. It contains reservoirs of biological potential even in places you may think of as unwanted. Fat is not just stored calories. It houses stem cells. It sends signals. It influences immunity and metabolism. Under the right conditions, it can even support regeneration. The real question is not whether your body has power. The question is whether that power is being suppressed or activated. And that's where the story truly begins. For decades, we've been told a simple story about body fat. It's storage. Extra calories go in, fat cells expand, and that's the end of the explanation. But that story is incomplete. Body fat is not just storage tissue. It is a living, active organ. It communicates with the rest of your body every minute of every day. Inside your fat tissue are stem cells, adaptable cells capable of becoming new fat cells, but also capable, under different conditions, of supporting repair in other tissues. Fat also produces hormones that influence appetite, inflammation, insulin sensitivity, and metabolism. And surprisingly, a significant portion of your immune system interacts directly with fat tissue. Healthy fat is not the enemy. Your body needs it. It cushions organs. It stores energy. It participates in hormonal balance. The problem begins when fat expands beyond healthy levels. As fat tissue grows, it demands more blood supply. It builds new blood vessels to feed itself. It releases inflammatory signals. It alters how your immune cells behave. It begins to change the metabolic environment of your entire body. Excess fat doesn't just sit there quietly. It signals. It signals your metabolism to slow. It signals inflammation to rise. It signals insulin resistance to increase. Over time, that signaling environment becomes self-reinforcing. More fat leads to more inflammatory signaling, which leads to metabolic disruption, which encourages more fat storage. This is not a cosmetic issue. It is biological. Understanding fat as an active organ, not a passive storage bin, changes everything. Because once you realize that fat responds to signals, you also realize something else. It can be reprogrammed. And that opens the door to an entirely different strategy for health, aging, and metabolic control. If fat is a living organ, then like any living tissue, it needs nourishment to survive and expand. And that nourishment comes through blood vessels. This is where the story becomes even more interesting and more powerful. There is a biological process called angiogenesis. It simply means the growth of new blood vessels. Your body uses angiogenesis naturally for healing wounds, repairing tissue, and supporting normal growth. It's essential for life, but angiogenesis can also be hijacked. Tumors rely on it. A cancerous mass cannot grow beyond a tiny size unless it builds its own blood supply. Without new vessels delivering oxygen and nutrients, it simply cannot expand. Now here's the connection most people never hear. Expanding fat tissue uses the exact same mechanism. As fat grows, it stimulates new blood vessels to feed itself. It behaves biologically in ways that are surprisingly similar to how tumors behave, not in malignancy, but in growth strategy. More tissue requires more supply lines, and that means both fat and tumors share a vulnerability. If you regulate the growth of blood vessels, you regulate the growth of the tissue they feed. Researchers have identified natural compounds in certain foods that help modulate angiogenesis. Compounds like genistein in soy, EGCG in green tea, curcumin in turmeric, hydroxytyrosol in extra virgin olive oil, omega-3 fatty acids from seafood, and lycopene in tomatoes and watermelon. These aren't fat-burning foods in the simplistic sense. They are blood vessel regulators. They help create balance in a system that, when overstimulated, drives unwanted tissue expansion. When you begin to see fat not as an isolated problem but as a biologically supplied structure, a new strategy emerges. You don't just fight fat. You influence the environment that allows it to grow. Once you understand that fat growth depends on blood supply and that blood vessel growth can be influenced, the next question becomes obvious. How do we influence it safely, consistently, and long term? This is where food changes from something you burn into something that gives your body instructions. Most people think of food in terms of calories, energy in, energy out. But that's an outdated lens. Modern biology shows that whole foods contain bioactive compounds that interact directly with your cells. They switch genes on and off. They regulate inflammation. They influence how stem cells behave. They even modulate how blood vessels grow. Think of these compounds like tools in a Swiss Army knife. Genistein from soy doesn't just affect blood vessels, it also influences hormonal signaling. EGCG in green tea doesn't just act as an antioxidant, it interacts with metabolic pathways. Curcumin from turmeric doesn't just reduce inflammation, it affects cellular communication networks. Lycopene doesn't just give tomatoes their red color, it supports DNA stability and cellular resilience. These aren't isolated actions, they are layered effects. This is why certain traditional diets, Mediterranean, plant-forward Asian diets, consistently correlate with lower rates of chronic disease and healthier aging. It's not one superfood, it's a pattern of biological signaling. When you eat strategically, you are not simply reducing calories, you are reshaping the environment inside your body. And that internal environment determines whether fat expands or stabilizes, whether inflammation rises or calms, whether cells repair efficiently or accumulate damage. Food is not passive fuel, it is biochemical instruction. And when you give your body better instructions, it responds. If food is instruction, then one of the most powerful instructions it can deliver is protection. Every day, your cells are exposed to stress, ultraviolet radiation, environmental toxins, metabolic byproducts, normal wear and tear. Over time, that stress damages DNA. And when DNA damage accumulates faster than it can be repaired, risk rises for cancer, for aging, for cellular dysfunction. Here's where certain foods quietly do extraordinary work. Lycopene, found in tomatoes and watermelon, integrates into your tissues and acts like an internal shield. Studies show that regular intake can significantly reduce oxidative DNA damage, even helping protect skin cells from ultraviolet exposure from the inside out. Kiwi is another example. Rich in vitamin C and polyphenols, even one kiwi per day has been shown to reduce measurable DNA strand breaks. Increase that intake, and DNA repair mechanisms become more active, like sending out a road crew to patch microscopic damage before it becomes a problem. This isn't about mega doses or exotic supplements. It's about giving your 40 trillion cells the raw materials they need to defend themselves. And when your DNA is protected, everything downstream, immunity, metabolism, resilience, becomes stronger. By now, you can see that fat is more than storage. It grows blood vessels, it signals inflammation, it influences metabolism, but it also contains something even more powerful: stem cells. Adipose tissue, your body fat houses adipose-derived stem cells. These cells are remarkably adaptable. In their native environment, they tend to support fat tissue itself, but change their environment and their behavior changes. Place them in damaged heart tissue, and they can assist regeneration. Place them near injured nerves, and they may support repair. Keep them in expanding fat tissue, and they help create more fat. Stem cells are context-dependent. They respond to signals. This is critical, because it means the goal is not simply to remove fat or eliminate stem cells. The goal is to influence the signals those cells receive. Certain dietary compounds, as we discussed earlier, can help regulate how these stem cells behave, slowing excessive fat cloning while supporting healthier cellular function elsewhere. Your body already contains regenerative capacity. The question is whether your internal environment is encouraging expansion or balance. And that balance is shaped daily by what you eat, how you move, and how much excess fat signaling is present. Most people think of the immune system as something floating in the bloodstream, white blood cells patrolling for threats. But immunity has geography. About 70% of your immune system lives in your gut, embedded in the lining of your intestines. That makes sense. Your digestive tract is a major entry point for the outside world. What surprises many people is this: a meaningful portion of immune activity also resides in fat tissue. Healthy fat helps coordinate immune responses. It communicates with immune cells, helps regulate inflammation, and participates in metabolic balance. But when fat expands excessively, that relationship changes. Enlarged fat tissue becomes stressed. It becomes oxygen deprived in its center. It begins releasing inflammatory signals. Immune cells inside fat shift from protective to pro-inflammatory behavior. Over time, this chronic low-grade inflammation disrupts metabolism, weakens immune regulation, and increases vulnerability to disease. This is why excess body fat is linked not only to metabolic conditions, but also to impaired immune response and higher risk of chronic illness. Fat is not just passive padding. It is immunologically active, and when its signaling environment becomes unhealthy, the effects ripple through your entire system. Balance fat, and you help restore immune balance as well. For years, we've accepted a simple belief: as you get older, your metabolism slows down. It's inevitable. It's natural. It's just aging. But a massive global study challenged that assumption. Researchers analyzed metabolism in over 6,000 people, from just days old to 90 years old, across 20 countries. Using precise measurement techniques, they tracked how energy was processed throughout the human lifespan. What they discovered reshaped everything. Human metabolism follows 4 distinct phases. From birth to age 1, metabolism surges about 50% higher than adult levels. From ages 1 to 20, it gradually declines toward adult baseline. From 20 to 60, it remains remarkably stable. From 60 to 90, it declines modestly, only about 17%. Let that sink in. From age 20 to 60, your metabolism is hardwired to stay steady. That means weight gain in midlife is not automatically caused by a collapsing metabolic engine. Your system was designed for stability during those decades. So if metabolism isn't naturally failing during midlife, what is disrupting it? That question leads us directly to the role of excess body fat and the signals it sends. Because when researchers adjusted for one critical variable, the picture became even clearer. Here's where the story takes a dramatic turn. When researchers analyzed that large metabolism dataset, the numbers initially looked chaotic. Every person's metabolic rate seemed different. No clear pattern, no obvious structure. But then they applied a powerful adjustment. Using advanced modeling, they accounted for body size and, crucially, they adjusted for excess body fat. When they removed the metabolic impact of excess fat from the data, something astonishing appeared. The human metabolic pattern became clear and consistent across ages. Stable from 20 to 60, only modest decline after 60. But when excess body fat was added back into the equation, metabolism dropped sharply. It didn't just shift slightly, it was suppressed. This changes the narrative completely. It's not that you were born with a slow metabolism. It's not that your body gave up at 45 or 55. Excess fat doesn't happen because metabolism slows. Metabolism slows because excess fat alters the biological signaling environment. That's the reversal. And that reversal matters because what can be altered by signaling can also be restored by changing the signals, which means your metabolic story is not finished. Once you understand that excess body fat suppresses metabolism, the next question becomes, how? It's not just about weight. It's about signaling. As fat tissue expands, it demands more blood supply. It releases inflammatory molecules. It disrupts insulin sensitivity. It alters how your cells process energy. Over time, this creates a metabolic environment that favors storage over burning. Inflammation interferes with mitochondrial efficiency, the tiny power plants inside your cells. When mitochondria become less efficient, energy production drops. When energy production drops, your body compensates by conserving fuel. That feels like a slow metabolism. Excess fat also alters hormonal signaling, including leptin and insulin, which regulate appetite and energy use. When those signals become distorted, your body behaves as if it needs to store more. not burn more. This creates a vicious loop. More fat, more inflammation, weaker mitochondrial function, slower metabolism, easier fat storage. But here's the empowering truth. That loop is not hardwired. It is driven by signals, and signals can change. If excess fat suppresses your metabolic engine, then restoring metabolic balance begins with reducing the very signals that are crushing it. When excess fat expands, it doesn't just sit quietly under the skin. It alters the entire metabolic conversation happening inside your body. Inflamed fat tissue releases chemical messengers that increase systemic inflammation. That inflammation interferes with insulin signaling. Impaired insulin signaling makes it easier to store energy and harder to burn it. Reduced fat burning leads to further fat accumulation. This is the feedback loop. More fat leads to more inflammatory signaling. More inflammation leads to weaker mitochondrial performance. Weaker mitochondria lead to lower energy output. Lower energy output encourages further fat storage. Over time, this loop can feel like destiny, as if your body is working against you. But it isn't destiny, it's biology responding to signals. And here's the critical insight. If the loop is driven by signaling, it can be interrupted by changing the signals. Regulating blood vessel growth, improving mitochondrial efficiency, reducing inflammatory load, stabilizing insulin response. These are not extreme interventions. They are gradual shifts that restore balance. Your metabolism is not broken beyond repair. It is responding to its environment. Change the environment and the system begins to recalibrate. If excess fat suppresses metabolism through inflammatory and vascular signaling, then the solution is not punishment, it's recalibration. And recalibration begins with daily inputs. The same foods we discussed earlier, soy with genistein, green tea rich in EGCG, turmeric containing curcumin, extra virgin olive oil with hydroxytyrosol, omega-3s from seafood, lycopene from tomatoes and watermelon are not miracle cures. They are biological nudges. They help regulate angiogenesis, the blood supply that feeds expanding fat. They reduce inflammatory signaling that interferes with mitochondria. They support DNA repair and cellular resilience. They influence how stem cells behave within fat tissue. This is not about extreme dieting or deprivation. It's about shifting the internal environment from one that promotes expansion to one that promotes balance. Small, consistent choices accumulate. When you repeatedly expose your cells to compounds that calm inflammation, stabilize signaling, and improve metabolic flexibility, you weaken the feedback loop that crushes metabolism. Food becomes less about restriction and more about restoration. You are not fighting your body. You are giving it the signals it was designed to respond to, signals that help resurface the stable, hardwired metabolism you were meant to maintain. The most empowering discovery in all of this isn't about stem cells or blood vessels. It's about design. Human metabolism is hardwired for stability from age 20 to 60. Even after 60, the natural decline is modest, roughly 17% over 3 decades. That is not collapse. That is not failure. That is gradual adaptation. Which means something important. Feeling dramatically slower, heavier, or more inflamed in midlife is not your biological destiny. Your body was not programmed to fall apart at 45. It was not designed to shut down at 55. It was not meant to lose resilience at 60. Excess fat signaling, chronic inflammation, and disrupted metabolic feedback loops distort what your body was built to maintain. When those pressures are reduced, your underlying metabolic stability begins to resurface. This is why 60 can feel dramatically different depending on internal conditions. The goal is not to become 20 again. The goal is to remove what is suppressing your natural baseline. Because your metabolism is not gone. It is waiting to be uncovered. At this point, it would be easy to overpromise. Stem cells, metabolism, angiogenesis, DNA protection, it all sounds powerful, and it is. But responsible science requires perspective. Much of this research is still evolving. Some findings come from laboratory studies, others come from epidemiological patterns or early human trials. Not every mechanism has been fully mapped in long-term clinical outcomes. That doesn't diminish the importance of what we've learned. It simply means we are at the beginning of a deeper understanding. What is clear is this. Excess body fat is not passive. It alters immune signaling, vascular growth, and metabolic regulation. And whole foods contain bioactive compounds capable of influencing those same pathways. The opportunity is not to chase miracles. It is to make informed, sustainable changes that align with how your biology actually works. Avoid hype, avoid extremes. Instead, focus on patterns, consistent dietary choices, movement, metabolic balance, and inflammation control. The science is opening the window. We are seeing more clearly how interconnected these systems are. And even at this early stage, one truth stands out. Your body is more adaptable and more powerful than you've been led to believe. Step back and look at the full arc of this story. Fat is not just storage. It is a signaling organ. It houses stem cells. It influences immunity. It demands blood supply. Excess fat doesn't merely add weight. It changes the biological environment inside your body. It amplifies inflammation. It suppresses mitochondrial efficiency. It distorts hormonal signals. It creates a feedback loop that makes metabolism feel broken. But here's the most important truth. Your metabolism was never designed to fail in midlife. From 20 to 60, it is meant to be stable. Even beyond 60, the decline is modest. What crushes that stability is not age alone, it's accumulated metabolic disruption. And disruption can be reduced through food that regulates blood vessels, through nutrients that protect DNA, through compounds that calm inflammation, through choices that shift signaling patterns. This is not about chasing perfection. It is about removing interference. Your body already contains regenerative potential. It already knows how to maintain balance. It already has the blueprint. The goal is not to build something new. The goal is to resurface what was there all along, a metabolism designed for resilience, not decline.